So right now we're going to practice assigning oxidation numbers to atoms that are in polyatomic ions and molecules and ionic compounds. And before we do this, we're going to ask ourselves, why are we even doing this? Remember, we're using oxidation numbers as a way of helping us keep track of electrons in a redox reaction. So we're not actually applying the concept of oxidation numbers today. We're just practicing on learning how to assign them. And we'll start applying them tomorrow. Before we get going on this, let's refresh ourselves with the rules. Hydrogen is +1, and there's a couple of exceptions. Oxygen is a -2, again, a couple of exceptions. For an ion, the oxidation number is the charge on that ion, like Na+, its oxidation number is +1. And then for anything, the sum of the oxidation numbers is the overall charge. So the sum is equal to the sum of the oxidation numbers is equal to overall charge. Now, when it comes to actually writing oxidation numbers with these polyatomic ions and compounds, there isn't a conventional way that we notate it or indicate it. Usually it'll just be like you'll be given a formula and somebody will say, what's the oxidation number of oxygen? And you enter it in. But there isn't like a spot for us to write it on the formula. We just kind of write it wherever we want to. So I'm going to do it kind of like this, like a table. What's the oxidation number of oxygen? What's the oxidation number of hydrogen? Well, these are both in our rules. Hydrogen is +1. Oxygen is 2-. When we add them up together, the charge of the OH- is a -1. So when we add these together, they better equal -1. And they do, so we know we did it right. So that was a pretty simple example. Let's try the next one. We have sulfur and we have oxygen. We don't have a rule that instantly tells us what the oxidation number is on sulfur. So for now, we don't know what it is. For oxygen, we know that oxygen is -2. Also that there are 2 oxygen atoms in this molecule. So altogether, if we add them all together, the oxygen's total oxidation number is a -4. The charge on SO2 is neutral. It has no charge. So that means that whatever sulfur's oxidation number is, when we add it to -4, it has to equal 0. So we can use some clever math to figure out that sulfur must be +4. Probably the reason why I love this chapter so much is because it's got a lot of really easy algebra in it. So let's do this Cr2O7 2- next. We have chromium, we have oxygen, we have an overall charge of 2-. So we know that when we add these up, they're going to equal 2-. We know that oxygen is a -2, and we have 7 oxygen atoms in this ionic polyatomic ion. So all together, the oxygens are going to have a -14 oxidation number, like when you add it all together. So in order for this to work out right, the sum of all the chromium's oxidation numbers has to be +12. +12 -14 is equal to -2, which is our charge. So how many chromiums do we have? We have 2 chromiums, and all together they have to be summing up to a +12, so that means each chromium's oxidation number must be +6. So this is kind of fun, right? Let's try this one. Sodium, carbon, and oxygen with an overall charge of 0. We know oxygen is -2, and we have 4 oxygens, so that's going to add up to a total of -8. We don't know what carbon is, but we've got 2 of them. We know that. And sodium, so whenever you see sodium or lithium or potassium or any of those group 1 or group 2 ions, or atoms, sorry, group 1 or group 2, they are always just plain old normal cations. So sodium in any kind of compound is just the Na plus ion. So this is a +1. Remember that for a simple monatomic ion, its charge is equal to its oxidation number. And we've got 2 of those sodiums, so together they're a +2. So we have some math to solve here. +2, and then whatever carbon is, -8, has to add up to 0. So that means that the total of the carbons must be 6, and that means that each individual carbon must be a +3. Let's do the next one. We have chromium and we have oxygen. We have a total charge. Cr2O3 has a total charge of 0. We have, for oxygen, we know its oxidation number is -2. We've got 3 oxygens in this formula, so altogether they are a -6. Chromium, we don't know what its charge is, but we know that we have 2 of them, and altogether their charge must be +6, so that it adds up to 0. And so we can figure out that chromium must be +3. Each one must be +3. So now that you're probably kind of getting the hang of it, now I'm going to give you this one down here, which is just crazy tricky. There's 1, 2, 3, 4, 5 different atoms in it. Let's try to set it up the same way. We have nitrogen. We don't know what the nitrogen's charge is. How many nitrogens do we have? We have 2. We don't know what it is. Hydrogen, we know that hydrogen is always +1. And how many hydrogens do we have? We've got 8 of those, so that's a +8. Ce, we don't know what his oxidation number is, but we only have 1 of him. Sulfur, we don't know. Remember that even though we've had other problems on here with sulfur, like up here, sulfur was a +4, the oxidation number for everything is not always exactly the same. So sulfur, it could be a variety of different things. We don't know what it is. Like here, for example, chromium was +6 here, and down here it's +3. So it changes. So we don't know for sure what sulfur is. How many sulfurs do we have? We have 3 sulfurs. Don't know what that is. Oxygen we know is -2. We have a total of 12. So altogether that's a -24. That's a lot. And the charge on this overall has to be 0. So all of these are going to add up to 0. But that's really hard. How are we going to figure that out? We have 3 unknowns. And we only have 1 equation, which is mathematically impossible. We can't figure it out. Don't worry, though. We have a solution. So in a really tricky problem like this one, what you need to do is take this compound right here and divide it up into smaller pieces. And those pieces that you're going to divide it into are your friends, the polyatomic ions, which are standing out for you in their little parentheses. They're just like saying, the parentheses are saying, notice me. I'm a polyatomic ion, pay attention to me, I can help you. So we're going to look at the polyatomic ions one at a time. We have the NH4+ ion, and if you can't remember the charges on them, that's fine. Go find a table of polyatomic ions and look the charge up. So we're going to just treat this guy all by itself for starters. We have nitrogens, we have hydrogens, we have an overall charge of +1. We know that we don't know what the nitrogen charge is. We've got 1 of them. No idea. Hydrogen, we know is +1. We've got 4 of those, so altogether their charge is a +4. And this has to add up to a +1. So that means that nitrogen must be -3. Nitrogen must be a -3. So we've got nitrogen figured out. Let's come back to the big molecule. Let's fill in our -3. In the big molecule, we actually have 2 nitrogens, so altogether they're going to be a -6. So we've got 1 done. That's not so bad. Let's focus on our second polyatomic ion. We have SO4. Go find a table of polyatomic ions and you'll see it's a 2-. We've got sulfur. We've got oxygen. We don't know what the charge is on the sulfur. We've only got 1 of those sulfurs though. Oxygen we know is a -2. We have 4 oxygens. That's a total of -8 for all the oxygens. And the charge on this bad boy is a 2 minus. So these have to add up to 2 minus, which means sulfur has to be plus 6. There's only one of them, so it's a plus 6. So that means we go back over here. This guy is a plus 6. So now, are we in a position where we can actually figure out what the charge is on this cerium, Ce? Wait a minute. Almost made a fatal error. Sulfur is plus 6. And there are 3 of them for a plus 18 total. So now, can we figure out what the charge is on Ce? We definitely are able to figure this out. Maybe we need to use our calculators to do the math on this. I mean, I feel like I don't necessarily trust myself. Minus 6 plus 8 plus 18 minus 24, that totals up to a minus 4. So that means Ce must be plus 4. Let's do that math again. Minus 6 plus 8 plus 4 plus 18 minus 24. That adds up to 0. We did it.